right angles are congruent. And you kind of saw that when you did your folding activity. All the right angles are congruent because they are all what measure? 90 degrees, okay? If two lines, and that's an S, are perpendicular, then they intersect to make 4 right angles, which is kind of, again, basically what you saw in your investigation. All right, based on this stuff right here, these properties, this is the kind of stuff you're going to do in your homework. So before we start this, let's look at this picture. They gave us this. What does this mean? Yeah, this means that line T is perpendicular to line what? Line what? R. And line S is perpendicular to line R. So if this is true, then what can I say about this angle, you guys, right here? That's 90. This is 90. And that's 90, correct?
Right.
I know that because we proved it kind of when we looked at. Those are all 90 also. So draw those in there, and let's see if we can answer these questions. All right. Angle 3 is perpendicular to angle 5. Is this true? Angle 3 is congruent, not perpendicular, congruent. Is that a true statement?
Yes.
How do I know?
They're both 90 degrees.
You have to put a reason. Okay? So you always have to put a reason. All right angles are congruent.
Really?
That's a property of a perpendicular line right here.
Sweet.
Okay, angle 4 and angle 5. What can we say about those? Are they congruent?
Yes.
How do I know that? There's actually 2 reasons. The first reason I thought of from chapter 2. What kind of angles are 3 and 4? Vertical, right?
Oh, I got it.
So I know they're congruent, which means if 3 is congruent to 5, then because of the vertical angle theorem, 4 is also congruent to 5.
Really?
Ooh.
Blowing my mind.
I know. Angle 4, write this down and don't write too big, is vertical to angle 3. So, because of that, I can also say that angle 4 is congruent to angle 5. That's one reason.
What's the other reason?
Then I want you to come down here and write the other reason based on perpendicular lines. We could also say,
And choose.
since line T is perpendicular to line R, 4 is a right angle. I know, you're going to have to get used to explaining. All right angles are congruent.
Why do we have to explain
Because that's what writing proofs is all about.
that? This is Bruce right
You're leading up to it. We're leading up to it.
We're just
Okay? They're not as hard as you think they are. All right, angle 2 and angle 3. Can we say that angle 2 is congruent to angle 3?
now.
Why can't we? Because we don't have enough information. They did not put a little box here to tell us that those are perpendicular. So we got to say no, we don't have enough information.
So on a test if that happened, if we guess wrong.
Yes, you'd have to put, well, if you put yes, you have to put a reason. And you won't be able to come up with a reason. So it's got to be no, okay?
You can tell by looking at it.
You can't give that as a reason. Sorry. Okay, turn the page. On your own, I want you to take a minute to answer 1, 2, 3, and 4, just like we just did. You don't have to do 5 and 6 because,
All by ourselves?
yeah, it's just like what we just did.
Alive.
Practice what we just talked about. 5 and 6 are kind of redundant, so we don't need to do that. Here's my reasoning. Maybe it's similar to yours. You might have written it slightly different. But for number 1, angle 6 is congruent to angle 10. We know that because they are both right angles and right angles are congruent. Just had to write a little short statement there. Number 2, 7 and 10. Okay, it's the same as the page before. You could have talked about vertical angles, or you could say since line G is perpendicular to line E, angle 7 is a right angle, and all right angles are congruent. So yes. Number 3, there's not enough information to say that 6 is congruent to 8. What's the problem? What's missing over here? Why can't I say it? Because there's nothing here. What, Morgan?
We don't know if 8 is 90 degrees.
Yeah, you can't just say it doesn't look like it. You have to say we don't know that there's a right angle here. We weren't given that information. There's not enough information. Okay. Number 4 is yes. Angle 7 is congruent to angle 11, again, because these two lines are perpendicular. That means 7 is a right angle. These two lines are perpendicular. That means 11 is a right angle, and right angles are congruent. Got it? We'll practice. Okay. Intersecting perpendicular lines. Here we go. These are the theorems. Do you need to know the theorem number? Nah. I'm just telling you because that's what's in the book. Okay, 3.3 and 3.4. Here we go. If two lines intersect, that is not acceptable.
It was a high five.
To form two adjacent congruent angles, then the lines are perpendicular, and they would have to be 90 degrees. Basically what they're saying is if you have two lines that intersect and form two congruent angles, they have to be perpendicular. It's the only way it would work. If this angle is this equal to this angle, they have to be perpendicular. They have to be 90 degrees if two lines intersect. That's what it's saying. Okay? Here it says if two adjacent angles have a pair of perpendicular sides, then they are complementary. It doesn't ever go away.
What's that line thing? Upside down.
Perpendicular. It's perpendicular. So what this is saying is, if we have a pair of adjacent angles that has a pair of perpendicular sides, so here we have adjacent angles, and they each have a pair of perpendicular sides, then they are complementary, which means they add up to what?
90 degrees.
Yes. Angle A and angle B add up to 90. Because of the perpendicular theorem, theorem 3.4. All right, so we're going to use the same knowledge that we used before, and we're going to solve for y here. In the diagram at the right, ray EF is perpendicular to EH. Basically, I know then that this means that this is how many degrees? 90. And if GEH is 30, find the value of y. So they've given me all I need to solve this. I can say this plus this equals 90. 6y plus 30 equals 90. Okay, so then I solve by subtracting 30. And 6y equals 60, and y equals 10. This is based on theorem 3.4. That's that theorem right there.
you memorize it
There.
later.
No, you could just say adjacent angles that have a pair of perpendicular sides if you want. You don't have to memorize what it is. Okay? There probably is. Oh, okay. So that is what 3-2 is about. Do you want to do a quick would you rather break, or you want to just move on and finish this? Let's do a quick and stay focused. Transversal. This right here is a transversal. Okay? All right. Transversal is a line that intersects two or more other lines at different points. So, we're going to be working a lot with transversals. Really? Do you want me to take it away? Thank you. Just hold on, Aaron. All right, special angle pairs, corresponding angles. Corresponding means in the same spot. I'll show you what it means in just a second. Just write same spot, okay? They occupy corresponding positions like an F pattern, and I'll show you what I mean. Like an F pattern. It doesn't have to be a bad word. It's just, what else? What else do you see are corresponding angles? What else do you see? 1 and 5 and 3 and 7. Those are all corresponding angles. They're sort of in the same position compared to the transversal. Okay, what does the word alternate mean?
Like you go from one thing to another kind of.
Starts with, it's another word that may be true. You're right. It starts with an O, kind of like opposite, right on. Opposite, and then what does interior mean?
Like the back.
Inside. Okay, inside, compared to the transversal. It sort of makes like a Z pattern, sort of. Show you what I mean. So, compared to the transversal, we're looking for opposite angles that are inside. So, for example, like 4 and 5. See how they're on the inside, but they're opposite sides of the transversal. So that's 4 and 5, and then there's one other pair, 3 and 6. Alternate interior angles. Okay? All right, consecutive. What do you think that means?
Like all in a row.
Yeah, same side, all in a row. Same side. What does interior mean?
Inside.
Inside.
So like
Inside.
Okay, the transversal, compared to the transversal. Sort of makes like a C pattern if you want to look at it like that. But you don't have to. Just if you remember. So same side on the inside. What do you think there's 2 pairs of them?
3 and 5.
4 and 6 and 3 and 5. Same side on the inside. All right, again we have that word alternate, which means what?
Opposite.
Opposite, and exterior, which means what?
Outside.
Outside,
So you're saying like the one
to the transversal. Yeah. So, opposite and outside would be 1 and 8. See it? 1 and 8. And then one other pair. What would that be? 2 and 7. All right? So down here, this is the end. I want you to, before you wrap stuff up, I want you to do these right now. It doesn't take very long. Write down what you get. You can abbreviate. 2 and 7 are opposite and on the outside. So I'm just going to abbreviate. They would be alternate exterior.
Should we do 5 and 6?
So I want you to do all the